Hi, nice to have you back in this fourth lesson about point generation, PLEXUS effects and trails inside of Houdini. My name is Helge Maus from pixeltrain. In this lesson, we want to talk again about trails. This time, we want to use volumes inside of Houdini to generate trails. If you have seen the release of X-Particles 4 inside of Cinema 4D, you may be seen that one big feature there is a so-named flow field. A flow field is a vector field which can drive particle movements and trails and so on in a 3D space. And that's exactly what we want to build here inside of Houdini. For this, we need a little bit knowledge about volumes, and so let's get started. We add here a geonode so that we have a little new playground here, and I jump into this geo. We can make the other objects invisible here and go to frame number 1. Okay, here's my grid again. First, we need a volume, and Houdini is really good in working with volumes. You see, if you enter volume, you get a whole bunch of different volume nodes here, but this is only a part. This is the Houdini volume. But there are also volumes which are named VDB. VDB is an open standard, and Houdini is also capable of working with all VDB nodes here. And in this lesson here, we want to talk about the Houdini volumes, but you see this is a whole world which you can also explore. These are the VDBs, really, really powerful inside of Houdini. We add a standard volume, and it's represented by this nice cloud shape, and this is a hint for what you can use a volume, for example, for density. So if you want to have smoke, fog, pyro, and so on, we use these volumetric approaches. In our case, we want to store in our volume only velocity, so we want to drive particles or trails. So let us first look into this volume and what we get. A volume is a box, and we can size the box like you're used to. You can add here this volume, you have here a size, you can say where it's centered, and you can also manipulate it with the handle tool here to give it a size you like. Okay. If you use this input here, you get a bounding source. So if you have another object which has to be encapsulated with this volume, you can use also this input here. But for my experiment this here, is enough. Let us take 2, 2, and 2 as a size. Okay. The next step is we want to see what a volume exactly is. And if you hold down the middle mouse button here over this volume, you see this time we don't get primitives points or so, we only get a volume, and a volume is represented here at this point here. We have a field with the name 0, and this field is built from 10 to 10 to 10 voxels, which are in total 1000 voxels. What are voxels? Let us take a node which is named a volume slice node. And if you now hook this up here, and I template this volume, we can deactivate here this grid, you see a slice through this volume here, and you see these equally spaced rectangles here. And these are the slices through these boxes. So the whole volume is built of absolutely equal spaced and equal sized boxes. And these are named voxels. And in every voxel, you can store exactly one value. And the value you want to store there is defined here in the volume. Like I've said, if you hold down the middle mouse button here, you see the field is named 0. But we want to use a velocity field. So for this, we go here to the name of the volume, and we tell the system we want to use the name vel for velocity. This is a standard name. And if you hold down now your middle mouse button, you see, okay, our field is named vel, and we have 1000 voxels here. Because we can store only one value here, we sometimes need more of these fields, because a velocity is in 3D space, and we need 3 axes to store the velocity in which direction the particle has to go. And this is the rank. If you have a scalar volume, it means that you only have one value per voxel. If you go here and say vector, you think you have more values per field, but that's not true. If you hold down now here middle mouse button, you see, okay, velocity is split up into 3 fields, and every of these fields here have 1000 voxel. So they lie on each other and store the values. From the outside, we have val as a vector, but inside, yeah, you have 3 times the memory usage of these data fields. Okay. The amount of data fields, or the resolution of this volume, is made here with the uniform sampling divisions. So to the volume slice, we see the size of them. So if we bring this down, you see the field is extremely low in resolution. If you bring this up, you get more and more resolution, but keep in mind that you also get more memory use. You see here, you get more and more voxels. These voxels are in the moment empty, and this is the initial value here. And if you want to see something, you can go in here and tell in the first field, so val point x, you want to have a value of 1. And Houdini represents this as a color for you so that you can really see now here in the volume slice what's inside of this field. And yeah, this is the visualize here. You can change here how it's visualized, but in our case, we can throw this away and see the original representation of Houdini, which is a fog. So if you throw something in here, you see a fog here in the viewport. Now, we want to use this volume now to store vector data. And to bring something in, there are different approaches. And for this first step, we want to use a volume warp. So let us add a volume warp. The volume warp runs over the volume and addresses every voxel, and we can manipulate the data in these voxels. So let us dive in. Because a volume warp works with volumes, we have a little bit different globals and outputs this time. We have a volume global here on the left side and a volume output here on the right. And you see the standard value which is piped through is the density, because normally you use volumes a lot for fog, mist, and all this kind of way. So density is really obvious. In our case, we want to change the values of our velocity. And this is something we don't have in this list. If you have an attribute on a data stream and you want to bring it into a warp, you normally use a bind node. And like I've said, in this bind node, you can define here what you want to bring in, and then you can use it here. If you want to export this, we use a bind export node. And so we can tell now the system, okay, I want to use a bind export for val. Val will be not a float, but a vector, so 3 values. And then we can change now what is inside the val outside of this warp. The typical use here is the curl noise. So the curl noise defines here a vector. To get a changing vector, we need something which changes through space. This is the position normally. And this vector here we can directly pipe here to this bind. And now you see in your viewport, this is a fog representation of these values which come from the curl noise. And if you want to have more resolution, you can go back here to this volume node and increase this or decrease this. Houdini tries its best to represent this in the viewport. Okay. So now we have filled these voxels with vector data, and these vectors are now velocities for us. We can change here really fast the roughness. I don't want to have it too rough, but yeah, we can have a little bit of roughness here, something like that. Okay. Now we want to use this vector field for making volume trails. And for this, we have a node which is named volume trail. The inputs of this node are important. If you go over the first one, you see we need points to trail, and the other input is a velocity volume, and that's exactly what we have built. So we connect these two. When set this over, we get an error. Hold down the middle mouse button. Okay, we have not filled all the sources with the data we need. Okay, we need points. For this, I template here this volume really fast, and we can now use some points. Let us take, for example, a sphere here. I make a polygon out of this. Okay, make it smaller. Then we want to scatter some points onto the sphere. For example, 100. And then we can use these points here in the volume trail node. And directly you see now that these points are now moved through the field, because it's like a movement. The velocity moves the particles from their original position, which is the scatter node result, through space, and we get this here as a result. The volume trail node has some nice options here. We have the trail length, which we can animate later. So you see here the original position, and then how this velocity field now drives our particles through space. And if you take then a closer look here, you see that this edge here is a little bit jaggy, and this depends on the point resolution. You see here you have this point resolution, how many steps you want to have, and this is something you can change here by this slider here. Also, you have here a maximum number of steps you want to go through the volumes. This is also important. And yeah, the colors are made here with the visualize velocity at this point. So this is the first step in our tutorial. If you now need more space, you can increase the size here of our volume box. If you want to have now a different kind of movement, you can change here to the volume warp, here the curl noise. So if we have a little bit more of a roughness, or you want to animate this here completely, you can change the offset. These are all the techniques we had before, so you can use this here now exactly like we've done this before. But yeah, you see now your first trails here. Let us go out here and remove the colors here on these trails by deactivating visualize velocity. If you now want to render this, we have the same approach like in the last tutorials. It works, but these lines are extremely thick because, yeah, Mantra doesn't know how thick they have to be. So we can use an attribute create here. Add a width attribute here. We want to have it on the points as float and as value 0.01 or something like that. So we have our first trails. Let us switch back here to our setup. In the next step, we want to use something pre-built from Houdini. We generated our vector field here, better to say the values in the vector field at this point with this volume warp. But if you want to use Houdini's node setup, you can use a volume velocity node. And this node does exactly the same here. So we can bring this over. We need a volume here. So we want to use that here. And now we have to tell the system in the volume velocity which kind of movement we need. And if we go in here and tell the system, okay, I need a curl noise, you see there's our own tab for this. And if you add this, you directly get the curl noise representation here. It's exactly the thing we have done. And if you want, you can now change here the swirl size of our trails. Also the grain, if you like this, it really looks really, really nice. You have an offset for animating this kind of stuff. and because of it's time dependent, you get this really nice movements here and so on. But there's a whole bunch of more options here. For example, I deactivate this. We have a vortex function. So if you add a vortex here, you see that now our vector field is rotated around a point, which you can define here by the center. And the vortex itself has an angular velocity. So how fast this vortex moves, that's this value here. Also, you have a direction of the vortex. So if you don't like it like this, you want to have it in this direction, for example, you can change this. And also you can combine directions, animate these directions. Yeah, this is also a really nice option to play with. Like I've said, this is the speed here, the velocity speed. Then you have this radius here, which you can change. And we have a vortex ramp to shape this vortex. And you can combine this, if you like, with this noise here. For this, we have a scalar here. So we really can change this and take a look here. Nice. Then we have some more options you can look into. For example, you can use the velocity from points, or you can use the velocity or the movement of other object, and you also can use masks here. Really, really cool at this point. So now we have found some different approaches to work with these trails here. And in the next step, we want to talk a little bit about colors of these trails. The first step was that we have given them an attribute here for the width, so that we can really render them in a width which we like. That's the first step. But the next step would be, I want to have nice colors. So let us start here with the points we used. And a fast way of giving these points a color here is, for example, to add a color attribute with the attribute randomize. You also can use an image map if you like. So this is often used if you have grids, for example. We can have an attribute from map here, for example. If you now place this here, let us take a look here. Now you see our points are now colored. The reason for this is that in this attribute from map, we export the attribute CD, the point colors. And here you see it uses a UV color image here from the Houdini images. If you want to change this, you click here this file browser. And the interesting part is here on the left side, you see here the Houdini installation folder. And there's a whole pic folder here with pictures which Houdini brings. And if you want to see them all, deactivate here show sequences as one entry, and you can have the right mouse button, click here show images. It takes a while, and then you get here all the nice images side effects delivers for you. For example, this leopard 4 or the mandrill. And if you accept this, you see the point colors change, because now these point colors are used for the attributes which you define here, UVs. I don't think that we have UVs here. But yeah, we can see this a little bit better if you change the amount of points here. Yeah, now you see the mandrel here on this sphere. So that's enough. So if we now go to the trails, you see, we don't see the color anymore. Why? Let us take a closer look into our friend, the geometry spreadsheet. If you look here, you see in the moment the colors are there. You see you have a CD attribute for every point, and this maybe are the colors of the mandrel. But if you go here to the volume trail, and the volume trail is nothing else than points which are connected by primitives, you see the color seems to be there, but not for all. If you now scroll through, you suddenly see the original points have these colors, but not these points here, which are now generated by the volume trail. And if you have colors here, you normally have forgotten to deactivate here visualize velocity. So it colors then the points for your visualization. But in our case, if you don't do this, you get here value of 1. To color now the points, we use the attributes from here at this point. And there are different approaches. You can do that, more creative one or not so creative ones. You can use an attribute copy, for example. And here you have two inputs, the geometry to copy the attributes to. That's this here. And we have a source for the attributes, and we tell them, use them here. And if you now take a look here, now our strands are really colored, really nice. What does the system at this point? It takes the point CDs from the input here and copies them to the CDs at this point here. The attribute which is copied is here the CD, but what it uses is the localization of these points. And yeah, this is best seen if you bring the point amount down. You see that every strand here changes color because it moves through the map all the time. And yeah, this is a nice effect you can use, but sometimes you don't want that the color of the strands always change according to the position in space. But yeah, this is one idea of doing it with the attribute copy. So check this out, and we try another method, which is using an attribute promote node. Attribute promote has only one input here, and it is used for copying an information which is on one class of attributes. For example, a class would be points or primitive to another class. And you have to give a name of the attribute you want to copy. In our case, it's CD. And we get as a result a warning because this source and the destination classes are identical. To solve this, we can take the original class, which are point colors, and copy them to the primitives. But nothing changes in the moment here. The nice operation system of this node lies here. You have a promotion method. And here you can decide how or which rule is used to bring this over. And for this, you can take a look here in the geometry spreadsheet. If you look here on the volume trails, on the points, you see that these points here, which represent the mandrel, have all real color values between 0 and 1. The new colors which are generated by the volume trails are always 1, 1, 1. So it's the highest value you can get in a color. And so if you now go in here and change the method here to, for example, minimum, that means it always takes the lowest value, which is our mandrel color. And if you switch this on, you see exactly what you want. So now you have exactly your mandrel at this point here, and the strand is colored in exactly one color. That closes the tutorial for today. I hope you had fun and you've learned something about volumes and volume velocities, and also how to use here the attribute promotes and attribute from map. If you want to learn a little bit more about these vector fields, you also can take a look to other tutorials which use them. I hope I see you in the next lesson. My name is Helge Maus from pixeltrain.